So now let us begin our next plenary session. Okay? So plenary 2 will focus on energy issues and AI, how we balance efficiency, renewable integration, and sustainability while managing AI's own energy demands. To guide our session, we are pleased to introduce our moderator. He is a seasoned broadcast journalist, entrepreneur, and business professional with extensive experience in both media and corporate leadership. A former ABS-CBN reporter and PTV anchor, he has since held key leadership roles in sales and marketing, built several businesses, and now anchors programs on the Bilyonaryo news channel, focusing on business, finance, and entrepreneurship. Ladies and gentlemen, let us all welcome Mr. Robert Tan.
Thank you, Director Mel, for that introduction. Good afternoon, guests and speakers. I hope you had a good lunch. We have a lot in store for you for this session, a lot of speakers to listen to today. But before we formally begin, I would like to ask everyone to take out your phones and either scan the QR code. I think they're going to flash it behind me, or visit the shortened link, and in one word, please share your answer to this question. What should be the top policy focus when balancing AI's benefits and energy demands in the Philippines? So if you can do that, we'll flash your answers, and we'll see what the answers are from all of you. We'll flash it on the screen. So if you can scan the QR code and answer just one word. Am I right? It says here just in one word, what should be the top policy focus when balancing AI's benefits and energy demands in the Philippines? Sustainability. Yes, of course, we need sustainability. Optimization, solar energy, infrastructure. Consumer protection, yes, that's very important. Inclusivity, green, reasonable energy prices. Yes, I think we all want that. And what else? Awareness, yes, regulation. We do need that in terms of how we can balance how we use AI. Energy policy framework. So there's a lot of answers that we got from our guests. Thank you for giving us all that answers. We will be seeing that answered by our guest speakers today. And we'll start with this. As we know, the energy sector is both a beneficiary and a casualty of AI's rise. AI can improve efficiency and renewable integration, but its own energy demand poses risks. Now, this session asks, how do we balance these trade-offs through policy? And our first speaker is Dr. Marnie Shaw, Associate Professor and Deputy Director of the School of Engineering at the Australian National University with a PhD from the University of Melbourne. She applies socio-technical analysis and machine learning to chart pathways toward a fair, efficient, and decarbonized energy system. Now, please welcome Dr. Marnie Shaw. Dr. Shaw is joining us online via Zoom. Please join me in welcoming her to the session. Dr. Shaw, you may now begin your presentation. Good afternoon and welcome.
Good afternoon. Can you hear me okay?
Yes.
I have a bit of an echo.
Dr. Shaw, yes, you can start your presentation now.
Yeah, so it's really a really great pleasure to speak with you today, and I'm sorry I'm not there in person. I have a quite bad echo. Is there anything that you can do about the echo? I'll try it. Anyway, I'm so sorry not to be there in person. I really enjoyed the discussions this morning. So the conference theme for today is really very relevant and timely for the energy industry. And in Australia, we already have many energy companies jumping on board, using AI to improve how they work. And now government in Australia, just like around the world, is quickly trying to catch up, make sure we understand and minimize the risks associated with AI. So for today, I'm going to talk about why AI is so useful for the energy sector in Australia. And I wanted to give you some examples of how it's already being used. And then I want to talk about what I see as the key risks in using AI in the energy sector. So when it comes to running an electricity grid, the main task is to be constantly matching supply and demand. So that is power consumption and power generation. And AI is very, very helpful for that task because it's so good at forecasting both supply and demand. So that means it works really well for saving money both at the household level as well as for industry and for the grid. So let me start with some context around what's happening with our energy system in Australia. And I think that's really helpful to understand why AI is so useful for us. So in fact, in Australia, we have the highest rate of rooftop solar panels per capita in the world. So 1 in 3 homes has solar panels on the rooftop, including my home. And we have a new government rebate for home batteries, and that has led to a huge increase in installation of home batteries, around 200 per day. So what's happening is that we're moving to a highly distributed energy system. So in the future, we'll have around half of our future electricity needs produced from our own homes, and up to half of future battery storage and energy storage could also be from our home batteries and our electric vehicle batteries. So because we have so much cheap renewable energy powering our grid now, we're planning to turn off most of our coal generation in the next 5 to 10 years. So for this future grid, where really we have millions of devices producing and storing energy, AI will be the orchestrator. So forecasting, planning, operating the grid for the least cost, most reliable system. So I wanted to give you 6 real life examples of how AI is already being used in our energy industry. So I'll go through these quickly and I'll go into more detail for 3 of the examples because I know we don't have too much time. And I've got here in the blue text links to each of these examples so you can follow up later. So the first is an example of using AI for the household, so for demand management, and I'll go into that in a bit more detail. The second one is an example of using AI to coordinate and share household solar and batteries across a whole town. The third is an example of using AI as a customer service assistant, and this is a really interesting one because what we know in Australia is that we're not doing a good enough job of clearly communicating information to householders about energy. So we have, as a result, very low trust in the energy sector from households. So I personally am very interested to see whether AI can do a better job of this communication role, answering questions quickly, helping us to rebuild that understanding and trust. And then fourth, an example of using AI to improve planning of a whole electricity network. Fifth is an example of Tesla using AI to operate a large battery. So in Australia now we have very many of these very large batteries to store all of our wind and solar power, and the operation of all of those big batteries is supported by AI. And then the final example is the electricity market operators. So that's called AEMO in Australia, and how it uses AI for forecasting. So I'll go into a bit more detail for 3 of those examples. So the first one is a company called Amber Electric, and that's a retailer based in Melbourne. I really like this company. It was founded by 2 young Australians, and it's doing so well that this year the company was named in Time's top 250 green tech companies. So demand management shifts and shapes when we use energy and when we use our batteries. The AI learns the pattern for each household, schedules the battery, vehicle charging, hot water, and so on to come up with the cheapest way to power the house. So the second example is based on this beautiful town in northeast Victoria. The town is called Yakandanda, and the town is really far away from many big cities. In the past, it often had issues with power blackouts. So the locals have collectively decided to install devices that are powered by AI, and those devices can coordinate household solar and batteries to save money and provide backup power for when the grid is down. And then the final example is from another regional area of Australia called New South Wales. So Essential Energy is the network operator in that region. They run a huge network. In that part of Australia is a lot of farmland, a lot of open space, a lot of long power lines, lots of rooftop solar, and real bushfire risk. So there's lots of farms in this area who want to have more solar panels. There's lots of solar and wind farms wanting to connect to the network. That's challenging for the network operator because they don't have a good model of how much network capacity is available. So they're very conservative with how much they allow to connect. So as a solution, this network operator partnered up with a software company called Navea to develop a 3D AI-powered digital twin of basically the lines and poles of the electricity grid. And they used lots and lots of different types of data, maps, laser scans of the area, lots of data about the poles and the wires. And they built this AI-powered model of the grid that gives a much more accurate estimate of how much network capacity there is. So that means there's faster and safer to connect more solar and batteries to that part of the grid. So I think those examples give us a bit of a taste for the benefits that AI can offer to the energy industry. As we've already heard a lot about this morning, and it was a really fascinating discussion, there are, of course, significant risks when it comes to using AI. So I just want to speak to a few of those in the context of energy industry. So the first, and this was already mentioned this morning, is the lack of transparency. So black box AI models. So often we don't know why an AI model has a certain output, a certain decision. So in energy, obviously, if operators and regulators can't understand why the AI has made a decision, it can be more difficult to rely on that decision, especially in critical infrastructure like electricity. And then the second risk comes from biased or poor training data. So obviously AI models learn patterns from the data that we feed them. So for the electricity system, imagine if the data we fed the AI software underrepresents certain customer groups, then the AI model could systematically produce outcomes that advantage some people and disadvantage others. So another one is inequality impacts, and that's already a big issue in the energy industry. So really here we're using AI to maximize financial benefits for households who are wealthy and lucky enough to already have a home battery. So what about the households who don't have enough money for a battery or maybe live in an apartment and can't have one? So just thinking about sharing those benefits around. And then the last one I want to mention is around value insensitive decision making. So this is quite interesting. So I wanted to talk about a tiny bit more. So often what we need is AI models that are really sensitive to people's needs, values, and experiences. A simple example of that is with household batteries. So what we know from our research here in my research program is that not all battery owners will want the same outcome. So some owners will want to make the most money they can from their battery, while others actually care a lot about knowing what the battery is doing and why it's doing it. So around the transparency piece. And then there are lots of people who also don't care about the money. They just wanted the battery to be there, ready to provide backup power in case of a blackout. So all of these different priorities will result in a different operation schedule for the battery as planned out by the AI-powered energy software. And these personal priorities really need to be considered by the AI model. And that's not really happening at the moment. So all up, the way I see it is we need to focus on really three things for better use of AI in all industries, not just energy. So clear policies, informed people, and practical safeguards. I really liked Keith's summary this morning of the 3Gs: groundwork, growth, and guardrails. I wrote that down. So a particular point I wanted to highlight for the application of AI to energy is around building AI literacy. So there's a real danger, and this was discussed this morning as well, that when people are so fearful of risks and new technology that they become disengaged, and the opportunities to use AI in really helpful ways might be missed. So it's really important that we make sure people are really well informed and how AI is and isn't useful, and that they understand what we are doing around those guardrails, and that's clearly communicated to them. So I have some specific recommendations listed here, but I'm not going to go through them. What I wanted to sort of finish on was to step back and just think about what we're trying to achieve when we think about the opportunities of applying AI to the energy system. So I'm an optimist, and I believe that AI can help us solve the most challenging issues of our time. So for energy, that challenge is for us to stop using fossil fuels and minimize the worst impacts of climate change. And in the developing world, we also want to reduce energy poverty to zero. So I guess my main recommendation and the thought I want to leave you with is that we don't become so fearful of AI risks and overgovern AI that we lose sight of the opportunity to use AI to solve the greatest challenge of our time, which is to mitigate the worst impacts of climate change. And I'll leave it as that. And I thank you for your attention. I have my email here. If anyone wants to follow up with me, I'd love to hear from you. I'm looking forward to the discussion about how all of this applies in the Philippines.
Processing to artificial intelligence, and he recently collaborated with Amber Kinetics Philippines on renewable energy applications. Please welcome Dr. Navea.
Thank you very much. Are my slides on? Okay, so good afternoon, everyone. So while waiting, are there any intermission numbers?
Okay, while we're waiting for Dr. Navea's slides for his presentation, let's just go back a little bit about the presentation of Dr. Marnie. We've listened to it a while. Oh, there you go.
Okay.
Okay.
We go ahead. Okay, so let us start by greeting you, and again, good afternoon, distinguished guests, colleagues, and congratulations in advance to the organizers of this conference. So I'll discuss smart power, navigating the risk and rewards of AI in the global energy ecosystem. So connecting it to the previous talk and the overall theme of this plenary session, which is focused on energy issues and AI. Next slide, please. Imagine a world where AI is incredibly powerful in assisting humanity, but at the expense of humanity itself. What if we are investing our energy into something that could ultimately exhaust our resources and lead to scarcity? The global energy sector faces a fundamental and complex challenge, often termed as energy trilemma. This refers to the vital importance of simultaneously achieving three critical objectives. These are energy security, energy equity, and environmental sustainability. Energy security ensures a reliable power supply, while energy equity focuses on affordable and accessible energy for economic growth. And environmental sustainability aims for a transition to lower carbon emissions. Traditionally, these goals have been viewed as trade-offs, but current pressure requires simultaneous advancement in all three areas, presenting a significant challenge for policymakers and industry stakeholders globally. Next slide, please. In our current era, emerging as a transformative force in this landscape is the artificial intelligence. AI offers a package of capabilities that can fundamentally modernize energy systems. AI has significant applications in the energy sector, particularly in advanced forecasting, predictive maintenance, and grid optimization. It enhances predictions of energy demand and renewable energy output, helping to stabilize the grid. AI-driven analytics can preemptively identify potential infrastructure failures, such as transformers and turbines, thereby preventing outages and optimizing management. Furthermore, AI efficiently manages electricity flow across complex networks and integrates distributed energy sources, contributing to a more decentralized and renewable power system. Next slide. At DLSU, I was involved in the design of an integrated flywheel energy storage management system in partnership with Amber Kinetics Philippines. This system utilizes artificial intelligence to optimize energy storage functionality based on simulated real-time demands. By analyzing consumption patterns and predictive peak usage, we enhance the efficiency and reliability of energy management, contributing to sustainable energy solutions and reinforcing DLSU's commitment to advanced renewable technologies. To this date, Amber's Kinetic Philippines is already working on solar energy resources in tandem with flywheel technology. Next slide. So far, what we have used is narrow AI, which is one of the AI types available. AI can be classified both by capability and functionality. In terms of capability, there are three types: the narrow AI, which is specialized in specific tasks; general AI, which can perform any intellectual task a human can; and super intelligent AI, which surpasses human intelligence. Functionally, describes how AI learns and interacts with the world, including reactive systems like the chess player Deep Blue, which only respond to current inputs, similar to the AI in our cars. Limited memory AI, which can use past experience for better decision-making. Theory of mind AI, which can understand and emulate human thoughts, like some generative AI. And self-aware AI, which possesses its own consciousness and can act independently, as seen in fictional examples like Jarvis from the Iron Man movie. Next slide. The integration of AI is not without its own challenges. The operation of sophisticated AI models and the data centers that support them consumes a substantial amount of energy. The increasing demand for AI training and operation requires significant energy, which data centers consuming 12% of the total power in US, which is up just 4% before ChatGPT's release in 2022. These data centers not only require substantial electricity for server operations, but also advanced cooling systems, leading to a projected 15% to 20% rise in energy demand by 2030, according to Google, Microsoft, and Meta. The reliance on fossil fuels for electricity contributes to rising greenhouse gas emissions, with Google and Microsoft reporting increases of 47.4% and 29%, respectively, from 2019 to 2023. Cooling systems lead to high water consumptions, which data centers using nearly 1.7 billion gallons in 2021. Although individual AI tasks may seem energy efficient, the volume of daily interactions significantly drives up all energy demand, with global data center electricity consumption expected to double to about 945 terawatt-hour by 2030 and potentially reach around 1,300 terawatt-hour in 2035. Next slide. The growing electricity or demand for electricity, primarily driven by rapid deployment of AI in social media. Everyone who have created an AI.
Hello, good afternoon, everyone. Technical difficulty. Song and dance numbers, sir.
Okay, while we're waiting for the slides to come up. Okay, Attorney Ocaña, there?
This is...
Natatakot sa akin whenever I
Yeah,
try
no.
to interject.
Okay,
So,
there you
okay,
go. There
go
you
ahead,
go.
Attorney.
All right, okay. Maybe you should be here so that we don't encounter other technical difficulties. Anyway, okay, so good afternoon. My name is Norman Ocaña III, and today I will be sharing with you how Schneider Electric has utilized artificial intelligence, integrated AI in our solutions, as well as how we view AI in the context of economic development and policy formulation. So Schneider Electric is an impact company. Our mission is to be your trusted partner in sustainability and efficiency. We are present in over 100 countries and have been around for about 186 years. We have also witnessed and have been active players in the many megatrends throughout the centuries. Megatrends reshape the world and have massive implications socially, economically, and even politically. Some key megatrends of today, off the top of my head, are climate change, geopolitical shifts, and migration to rapidly urbanizing cities. But the two megatrends that brings us together in this room today are digital adoption and artificial intelligence. These two megatrends bring with them both wariness and excitement. They accelerate innovation and unlock opportunities that were once confined only in the realms of science fiction. And undoubtedly, the pace of digital adoption is accelerating. For context, and you'll see it here, it took 7 years for the internet to hit the 100 million user mark. In contrast, for generative AI, it only took 2 months. So 2 months and everybody was using it already. This rapid uptick of Gen AI has also accelerated the amount of data that can be consumed and processed in merely a few seconds. The more data that is consumed, as shared earlier, the higher the energy footprint of the data consumer. And the reality is we cannot put the genie back in the bottle. Like social media, AI is here and it is here to stay. And like social media, AI must be used wisely in order to serve society. By 2030, Gen AI-driven workload is expected to make up 60% of all data center computing requirements. Each Gen AI query requires 10 times more energy than your typical Google search. Therefore, plans to harness AI for societal benefit must also account for its rising energy demands. So at Schneider Electric, we recognize that AI is a game changer. We use AI in building solutions which allow our customers to optimize their heating and cooling systems. We integrate AI in technology for microgrids and renewable energy, which enables predicting supply and demand of variable energy in real time. Here in the Philippines, we have heavily used AI to optimize our manufacturing facilities in Cavite. This has resulted in reduced downtime, better inventory forecasting, and a shorter delivery time to our customers. All these uses, of course, require data that are processed in data centers. Data centers are at the heart of artificial intelligence and are premium assets in today's digital economy. However, despite this, data centers are also met with wariness because, as shared earlier, they compete heavily for key resources like water and energy. But again, the fact is data centers are not going away because, as mentioned earlier, digital adoption and use of AI are growing every day. And while a spike in energy consumption driven by digital and AI is expected, going digital and utilizing AI is also key in managing these spikes. IoT devices provide the data collection points that software and analytics work with to help reduce energy consumption and even drive down carbon emissions under the right circumstances. Which really brings us to the multi-billion-dollar question. What are the right circumstances? How can the Philippines push forward with digital and AI integration while at the same time managing the additional stress it brings to existing energy systems? Posed differently, if a genie appeared before us today and granted us 3 wishes to help address energy issues brought about by AI, what would these be? First, we would wish for a robust energy market that allows strategic sourcing of renewable energy. This will help end users optimize their cost as well as give them flexibility to switch among various RE providers depending on the time of the day. Second, we wish for a policy framework that encourages the building of on-site power generation sources, especially for heavy consumers like data centers. Generating power on-site will lessen the strain on the grid and can even provide excess power to the distribution utility. And third, we wish to make the integration of open source power management software and solutions a standard in energy-intensive industries. This would allow for better visibility between utilities and end users who wish to become prosumers. Interestingly, in the present, only 2% of the world's electricity is consumed by data centers. This means that there is a clear and present opportunity to build the right policy framework around the consumption of energy by artificial intelligence today. So this next slide, it's a little small, is a snapshot of our wish list. The people in this room are very well aware that policy drives market, and policy that encourages the growth and adoption of AI must always factor in the increase in computing power required. Strong and transparent collaboration across the energy landscape, including power generators, distribution utilities, and data centers as the end user is critical to keep this growth sustainable. If you fail to plan, you plan to fail. Benjamin Franklin, one of the foremost researchers in electricity. At Schneider Electric, we provide solutions for energy management across different sectors and along the 3 stages of energy optimization. We are grateful for this opportunity to strategize with you, and we hope to digitize and decarbonize with you as well. By working together, utilizing AI in a manner that solves some, maybe if not all, of the major issues plaguing the country is not a far reality. Because, as we all know, the moment to act is now. So this is the last of my slide. So thank you very much. Again, I'm Norman Ocaña. I'm from Schneider Electric. This is my LinkedIn profile. If you have questions, please feel free to add me and post your questions there. Or you can post it later during the panel discussion. Thank you very much.
Okay, thank you very much, Attorney Ocaña. Again, very insightful and very energetic presentation. Thank you. And up next is Attorney Monalisa Dimalanta, who served as the Chairperson of the Energy Regulatory Commission, or ERC, since assuming the role in August of 2022. Attorney Dimalanta has been instrumental in strengthening regulatory frameworks, accelerating rate reset exercises, and promoting transparent and fair power procurement. A seasoned leader in both the public and academic spheres, she previously led the National Renewable Energy Board, guided the creation of the Green Energy Auction Program, and continues to contribute as a professor at the Ateneo Law School. Please welcome Attorney Monalisa Dimalanta.
Thank you. Good afternoon, everyone, both here and on Zoom. While they are preparing my slides, wow, ang bilis. Okay. Natakot na sa'yo talaga. Okay. As we begin, I'd like to thank, of course, the organizers, PIDS, for this invitation. I was very excited to join you, and today more excited after I heard the morning panel and the discussions that were going on, because these are conversations that really need to happen, and I'm glad to be part, even to a small extent, of this important conversation. So, you know, over the last few weeks, there have been several discussions in various jurisdictions on this particular topic, on not particularly on energy, but on the future of AI. And even here, domestically, locally, a few days ago, I think almost 2 weeks ago, the E-Governance Act was passed. And this is a conversation that we really cannot escape anymore. So that's why this is very timely. In my own journey, AI journey, so to speak, which began more than 10 years ago, about 12 years ago, I traced this fascination and awe on the future of AI and the law. That's my mother field, law. It started, as I said, more than a decade ago, and I owe it to this gentleman. He doesn't know me. I have to give that disclaimer. But I have been following his writings, his works. His name is Sir Richard Susskind, and he has been writing about the law and technology, and then more recently about law and AI. My interest in his work began with my interest on access to justice and how technology and now AI potentially will increase the access to justice of ordinary citizens. So he recently, he's a very prolific writer, but I think early this year or late last year, he published his most recent book, his newest book called How to Think About AI, A Guide to the Perplexed. So it's a very reader-friendly, aka walang background sa AI, written book. So it's not that I'm promoting it, but I found it very useful not having that tech background to appreciate not only the history of AI, but its current state and its possible future state. And why do I say possible? Because the underpinning of his theory for that book, as summarized in this quote that I picked from the book, is that what we only see today are what our imagination today is capable of. So, and he said that in the context of discussing man's quest to walk on the moon. He said that when humanity, not just man, when humanity began to imagine how it's like walking on the moon, all that humanity could imagine was how to step on the moon, how it would feel like, what suit was needed in order to do that. But when it finally happened, what humans then, that when they started the journey, was not able to imagine was that when that moment would finally come, it would be shown, it would be seen by millions of people, hundreds of millions of people, via this box, which we now call the television, which will soon, baka ayaw ayaw ng ating mga friends sa media, pero baka maging obsolete kasi nga, hindi na tayo masyadong nagti-TV, di ba? What we use, sorry for our friends, what we use is now our gadgets, our phones, diba? So I'm sure at the time that humanity started walking on the moon and it was seen, televised, people then did not imagine that we would soon be able to watch it in something that can fit the palm of our hands. But that's the reality of the situation, and that's what technology presents to us. And so why do I begin in this context? Because all the discussions that we have today, and they have been wonderful discussions so far, wonderful insights, are limited by the imagination in this room. What we can imagine today. But when they finally happen, it is unlikely that it will be exactly as we imagined. Most likely, they will be beyond our imagination, even our collective imagination. So in the next few slides, what I hope to share are the limits of my imagination and the limits of what I can see in this area, in this space called the convergence of energy and AI. And in a way, because of the very useful, very helpful presentations ahead of me, they made my job easier. And what we did not speak, by the way, before this presentation. We did not coordinate our slides. But as it turns out, what I will be presenting in the next few minutes is sort of the way I have organized what they have shared so far and this morning. So I have identified 3 areas of convergence for energy and AI. Let me begin with the first, which is the area of operations. I think Attorney Ocaña earlier discussed this more deeply, where in generation, and I think even Prof. Roy discussed this earlier, in the area of generation, in producing electricity, AI has been helpful, has already been helping our plants, our power plants, do predictive maintenance para po maiwasan yung mga outages, which is what we want, the pain point that we want to avoid. But I think more importantly, as we increase renewables, the penetration of renewables in our system, AI in generation will be more useful in terms of, as we have less of those units that require preventive maintenance or predictive maintenance, we will see the value of AI in introducing more flexibility in our system so that we are able to harness the sun when it is shining and the water when it is flowing. And we can shift quickly as those resources are available. That's going to be the value of AI. For transmission and distribution, I think they also discussed this. As we are able individually, I don't know, I will ask because I'm a professor, I will ask for a show of hands. Sino po dito yung may solar panels na sa bubong? I recall earlier, Dr. Marnie said she has solar on her home rooftop, but I'm sure there are people in this room, including myself, that already has solar panels in their homes. While solar panels in our homes benefit us, of course, because we have, and this is a promotion, when you have solar installed in your houses, not only are you producing for yourself, where you become, as Norman had said, prosumer, not just a consumer, but a producer, but you're also able to save because of our net metering program, where you get rebates from your distributor, from your distribution company for the excess power that you export. So that benefits you, but sometimes it's also a headache for the distribution utility, especially if you are not registered. Kaya po, don't raise your hand na lang kasi baka hindi pala kayo registered. So, if you are registered and that means the distribution utility can see you, then they can manage your load better. But if you're not registered, then you are a headache to them because they can't see you in their system. They're not able to predict, are you not going to get from their system? Are you going to export to their system? They're blind to you if you are not registered. So if there is AI that will allow for better management of these networks, then that makes the job, not just the job of the distributor or the transmission network easier, but more importantly, they increase reliability in the system because they're able to forecast and predict. On the retail side, on the market and retail side, on the consumer side, I don't know if a lot of you are aware that we have a spot market in the Philippines. We have an energy spot market. It's a wholesale spot market. Do you know that we are already trading, and I'm sure Dr. Marnie is very familiar with this because we copied most of our rules from Australia anyway. We are trading on a 5-minute interval. So our market trades at 140,000 transactions a day. That's how much data that we have. And that's the energy market. We also have already a reserve market in our system. So that's that's in the operation side, how AI can help. On the second area of convergence, this is on consumer utilization or consumption. I won't dwell into this because I think the earlier presentations had a good discussion on this. But let me just talk about what is rarely talked about and what is really closest to my heart when we talk about the future of AI, which is off-grid electrification. We have more than 100, we have actually 250 islands in the Philippines that are not yet connected to the system. And they're on their own. If the only power plant in that island dies down or it malfunctions for that day, then there's no power for that day, for that entire island. So if we are able to introduce that flexibility of AI through hybrid RE, non-RE hybrid systems, then we will increase the ability to electrify these islands and really promote development in a more inclusive way in our system. Finally, the third area of convergence is on governance and regulation. We have talked about a lot of these points this morning, but let me just share that at the ERC, when I was still there, we began our digital journey in late 2022 when we started putting together a centralized database for our system. Wala pa pong database bago nung 2022. So that's when we started collating everything. Before that, everything was printed under the table of each, literally po under the table lang na nakatago sa cabinet ng bawat isang staff member. So this was really helpful. So quickly, time is up na daw po. But just 5 points that I wanted to share from an experiment that I did a couple of months ago. If anybody here was in the Giga Summit of Meralco, you know what this was about. I shared with them an experiment that I did. I asked ChatGPT, because AI is supposed to solve our problems, right? So I asked AI the main problem that we have at the ERC. So I typed, how do you reduce the electricity rates in Metro Manila, Philippines? So ChatGPT gave me several answers, but the main answer, and I tried several iterations of the question, the main answer, number one answer, is to renegotiate all power supply agreements and power purchase agreements. That's the first answer of ChatGPT in the 2 or 3 versions that I asked that question. But so that prompted me to, that gave or enlightened or gave birth to 5 pointers, 5 takeaways from that experiment. First is that the question, as we engage more in AI, as we utilize more AI, the first pointer we need to realize is that the question is more important than the answers. How we phrase the question. I was talking earlier to Prof. Roy, I said, I heard that there are courses on prompt engineering, and he confirmed there are already courses on how to craft your prompts, your questions properly, so that you will get a useful answer. Because it's garbage in, garbage out, right? So if you ask the wrong question, then don't expect a stupendous answer, diba? So that's the first point. Second point is that the answers, even if you have crafted the perfect question, the answer may not be something that you like to hear. So you have to be able to handle that before you hear the answer. Because you might just, scrap everything. Ayoko na to. Ang pangit ng sagot. Hindi naman pwedeng ganon, di ba? So we need to be able to be courageous enough, strong enough to face the answers that AI is able to assist us, which takes me to the third point. And I think this underscores even the discussions this morning, is that we need to define, we need to articulate, and we need to be aligned on what our values are. Dr. Marnie, I think, mentioned this also earlier, that it's the values, because it depends on what's important to you. But we need to be aligned as a group, as a society, what our values are, so that we can determine to what direction we will use this technology that's available to us. The fourth is I share this because as my recent former life as a regulator, this is really the temptation. That if we have AI, we surrender the accountability to AI, especially agentic AI. Because if we have already developed, for example, this tool of rate setting, it will determine for us what is the appropriate rate, power rate for this community for this period. Then you click send or click, I don't know, click a button. Then it gives us that amount and said, okay, that's what the AI said. And if we get challenged, we'll say, it's not up to us, it's up to the AI. You know, that's what the machine, that's what the model told us was the right answer. Then we need to be conscious about that temptation because it's so tempting, especially in light of current circumstances, to just say, to hide behind the computer, to hide behind the program. And then finally, in general, AI, I think, needs to be more than artificial. And I think that's a shared sentiment of everyone. It needs to be assistive, it needs to be accountable also, and it needs to be uplifting. So hindi po A yung uplifting, naubusan lang ako. Uplifting. So it needs to make us better, create a more inclusive society, and not, as was described earlier, widen the gap that's already existing in our society. So just a few points for us to consider. And thank you very much for listening.
Hey, thank you, Attorney Dimalanta, for that insightful presentation. Please stay with us. We're not done yet. May I invite also our other speakers, Dr. Navea and Attorney Ocaña, for our panel discussions. And for our on-site participants, you can write your questions on the provided paper that you have, and we'll take them live later on. And just raise your hand when you're ready so we can answer your questions later on. But as mentioned by Director Mel earlier, any questions that we, the panel, cannot answer here can still be asked on a one-on-one basis with our speakers at the fireside chat outside after the session. Is Dr. Shaw also with us right now on Zoom to join us for the panel? Hi, Dr. Shaw. Okay, before we get to the questions of our guests here today, I'll pose this question first for you for an international perspective. Dr. Shaw, based on your research on energy and AI, now what do you think can developing countries like the Philippines learn from the experiences of developed countries? Let's say, like, you know, the best practices that we can do here.
Yeah, so I think a really important place to start, and I really liked Monalisa's talk around this, is around the providing energy access to everyone. And so in the Philippines, that will be through microgrids on islands. So that is something that can be really improved in terms of efficiency. So now in Australia, we have rolled out hundreds of microgrids in the regional parts of Australia. Often they're still backed up by diesel, but they're primarily powered by solar and batteries. Batteries have gotten so much cheaper in the last couple of years. So now they're providing the cheapest form of reliable power to these remote parts of Australia. And I think that is a really important infrastructure to provide in the developing context.
Okay, thank you, Dr. Shaw. Now, when we look at the private sector perspective, this one's for Attorney Ocaña. From your perspective, how do you strike a balance now between investing in AI technologies and the realities of the Philippine energy sector, namely unreliable energy supply and a high cost of electricity here?
Okay. So for Schneider Electric, we do have our usual customers, the data centers, the buildings, the industries, but we also have a program called Access to Energy, which is precisely what the good doctor was saying earlier. The goal of that is really to provide energy to the far-flung areas, rural, remote areas, and I think that's how we can balance the demands of the market as well as the realities on the ground, which is some areas are just really not yet electrified or under-electrified.
And now if we look at the, for the academe perspective, Dr. Navea, now how can we strengthen the academe industry partnerships on AI energy research within a resource-constrained environment?
Okay, so for the academe and industry linkage, of course, the partnership starts with a common goal, and they usually execute an MOU, and then if there are some research efforts to do that, so there should be an MOA. And to strengthen that, there should be a strong engagement between the academic institution and the partner industry, wherein faculty can be deployed in the industry, and some industry partners can be employed in deployed in the university. So more than that, we can also develop some niche centers of research, which can work on with the industry together with the students in strengthening research towards this particular, let's say, AI issues and energy, and create programs from the undergrad level up to the graduate level so that the research and development can be strengthened.
So we really need to educate our
Yes.
students right now.
Yes.
Okay, and from a regulator's perspective, Attorney Dimalanta, this question's for you. Now, what type of policies do we need to ensure that AI development does not redirect scarce energy resources from important efforts such as the national total electrification?
I think there are, as I mentioned earlier in the presentation, AI can in fact accelerate the deployment of the National Electrification Program. But that means the National Electrification Program has to incorporate already the use of AI. And that means, I'm breaking this down in bite-sized pieces. That means the agencies, the National Electrification Administration and the Department of Energy, since they prepare the National Electrification Program, will need to not just be aware of the technologies and to avoid what we usually are prone to do, which is adopt a blanket approach. Like, for all of the islands, this is what we'll do. What we know by now is that we need, instead of a bludgeon, we need a scalpel to address the electrification requirements of our islands, because some islands will have high RE resources. Then for those islands, then we can deploy perhaps even 100% RE solution, like what Dr. Shaw was mentioning earlier, RE and solar and battery solutions. Then that will need to be incorporated in the program. For islands that are not as RE rich, then we can do a hybrid solution. But incorporating it in the electrification program is important, because that means that's the program, and I'm treading into some controversial grounds, because that means that's a program that will need to be budgeted, that will need to be included in the national budget for funds to be deployed for that kind of a technology. So it will require some work.
A lot of work.
It will require getting out of the box in the usual preparation modes and preparation frameworks that's currently being.
Well, but as you said, sometimes the truth hurts, right? Okay, now let's get to the questions of our guests. So we can ask the questions. Who's ready, sir? Where? Okay. Okay, can you state your name and your organization and who the question is for?
Yeah, I'm Dr. Paulo Lim from the University of Asia and the Pacific, and my question is particularly for Dr. Shaw and Attorney Dimalanta, because I think because you've talked about, let's say, how AI can be used in the energy sector. Now, one of the things that has come up lately about the use of AI for consumers is that it has been criticized for, let's say, providing two different prices to two different consumers looking at the same product. Okay? I mean, this was, for example, something in airfares, for example. So my question is, do you see concerns about price discrimination in the energy market that AI could spawn up? Because I think this is also to your point, Attorney Dimalanta, about transparency in AI. Because that's what I heard there. Thank you.
Attorney? Or Dr. Shaw, you can start.
I'm not sure if I've totally understood the question. So is the question about people being charged
Are there
different
concerns?
amounts of money for...
Yeah, are there concerns that AI could be, is that a concern that we should be worried about? That AI can be used to offer two different groups, two different tariffs for energy prices?
Maybe I'll pass it over to the attorney while I'm thinking about it in the Australian context.
Okay, Attorney Dimalanta.
Yes. Okay. Yeah, I think the answer is yes, it's possible because, well, for several reasons, not necessarily evil reasons, but it could be as benign as maybe the two groups ask different questions. That's why different answers were provided to them. That's why I mentioned earlier, we need to spend time crafting the questions, perhaps more than generating the answers. So that's the first reason. The second is that, and I don't know if this is really uniquely AI, but or the result of AI adoption, but I think the more we increase renewables in the mix, the more we will need to think about, hint, research topic, the more we will need to think about the pricing framework for electricity. Because as we move away from cost-based, I know we are a market, it's already a market framework that we adopt for the Philippine energy sector, but a lot of it is still cost-based. How much does it cost a power plant to generate 1 megawatt or 1 megawatt hour of electricity? And that's the minimum that the generator will need to get. But as we get more and more RE, which will not have significant operating cost, particularly no fuel cost, then we will need to move or think about moving from a cost-based to a value-based pricing system, wherein we will definitely get different answers, because the value to one consumer of this 1 megawatt hour is different from the value of that 1 megawatt hour to another consumer. So the quick answer, sir, is yes, it's possible, but we need to craft the framework so that we can also properly address the situation.
Okay, well, thank you for that, Attorney. Now let's move on to the next question. Sir, can you state your name and your organization?
Thank you. Dan Agustin from the Bangsamoro region. And to Dr. Shaw. On the predictive value of AI, can you predict the reduction of supply of energy? For example, that Qatar, for example, closed its diplomatic ties with Israel and to the rest of the world. Can you predict that the supply and also the price of energy? And to Dr. Navea, you talk about the solar system, renewable. Can you determine through AI what is the right mix between renewable and non-renewable? And to Dr. Ocampo on corporate strategy. by introducing AI, what is the impact of your employees? Did you reduce your employees? And on the financial side, was there an increase in revenue in the corporation? And to Dr. Dimalanta, in Singapore, decision-making, AI had been adopted in the decision-making in the judiciary. And our Supreme Court is studying now the incorporation of AI in its decision-making. Would you agree that in the ERC, AI should be used in making decisions, including the lawyers preparing the pleadings through AI research? Thank you very much.
Okay, let's start with the question aimed at Dr. Shaw, and the rest can think about what they're going to answer next. Dr. Shaw?
Yeah, that was a lot of questions. So in terms of predicting the price of supply, close to home in Australia, we are doing quite well with that in terms of our renewable electricity. So we know that solar and wind are intermittent. They're not there all the time, but they're quite predictable. So we can predict the supply, and that allows us to do a pretty good job of predicting price. That said, our electricity market is one of the most volatile markets in the world. So it's not exactly that easy to predict the price. And then I guess it gets even much more complicated when you're trying to predict price in an international context. So there we do have optimization models that are trying to work out the impact of particular tariffs and market forces on prices. But that is, of course, extremely difficult because we have ever-changing and hard to predict world events, including tariffs that are changing pretty quickly, and the impact of war and so on, which is very hard to anticipate. So I would say in an international context, it's very difficult. But close to home, luckily, it's quite, well, certainly we can do a good job of predicting supply by renewable electricity.
Okay, moving on. Attorney Ocaña.
Maybe
Dr. Navea.
I can answer. Okay, so about the mix of renewable and the one from the grid. Of course, AI can do that depending on the metrics of decision making that changes from RE to the grid. So for example, it could be the supply and demand concern of the grid. So where if there's a high demand for electricity, so we can possibly use the grid together with the RE, or they can be on a certain balance of percentage on where to use. So another could be the triggers when it comes to the current or the voltages required by each loads for each, let's say, community where it serves. And another could be localized depending on the area where this particular power system is placed. So for example, it is placed somewhere in Visayas. So there could be more of RE, more than the grid, because there are some areas which relies on RE. But in urban places, so mostly there would be a strike of balance between supply and demand, depending on that. So that input can be addressed by AI. But don't think about Gen AI, the general. It could be a localized AI, which is designed by the local company. So they designed it based on the metrics that they use for their particular decision making to switch. Actually, there's a switch gear that drives that control mechanism.
Okay, attorney.
Okay. So the first question to me is whether AI has led to job losses in the company. So no, because at least here for the Philippines, what the company does and what has done is encourage the use of AI by each of our employees, as well as integrated the same in the systems that we use. So it has in fact led to more productivity and a faster output. The second question is whether it has positively impacted the revenue stream of Schneider Electric. While I cannot give a definitive answer for that, as I'm not part of the finance team, what I can say is that Schneider Electric is heavy in energy management, and we have integrated a lot of AI solutions in energy management. This allows us to deliver better value and better optimization for our end users and clients.
Actually, that question, the first one about the workforce losing jobs to AI, I've heard a lot of the workforce really worried about losing their jobs to AI. Now, how can we be certain that it won't?
Well, I can speak for the context of Schneider Electric. And here in Schneider, aside from the commercial arm and the manufacturing arm, we also have the contact center, which provides high-value services for Schneider Electric all over the world. And in our experience, it has not led to job losses, because what we do is we see how AI can complement the work of the agents, of the engineers, and then they integrate it into their everyday work. So I think it's, to Dr. Navea's point, it's really more about getting comfortable with the technology and really upskilling so that the fear does not overcome what could possibly be.
So just look at it as a tool.
Yes.
Attorney Dimalanta, final question.
On the ERC side, yes, actually the ERC already started using AI in not to the extent, sir, of writing the decisions yet, but baby steps. Online filing, consumer complaint ticketing in an online platform, that's already in the ERC website. If you have a complaint for high billing or a sudden outage in your area, you can go to the website of ERC. There is a box there for consumer complaints. You can put your details and your complaint, and you are assigned a complaint number or a ticket number, and you can track the resolution of your case. For filings, for cases, for rates, for example, it's now online because the driver there is the desire to lessen human interaction, not to get some people out of the job, but to lessen the perception, if I may put it that way, the perception of manipulation or the perception of certain biases, for example. So we developed a program for an online filing system where the applicants are uploading already their petitions, their assigned folders, and they can also track the progress of the complaint. That's a bigger program is actually developed by and managed by the Department of Energy, called the EVOS platform, the Energy Virtual One-Stop Shop. That one is not just on case resolution, but even for licenses, for applications for licenses. So there is already there's already progress in the adoption of AI. But I must say that it is still there is still a high degree of discomfort, even among high officials, on the utilization of AI, and that's why we are not yet at the stage where decisions can be drafted or prepared by AI. But as I mentioned earlier, Sir Richard Susskind, the guy that I was, who I hope is my friend but does not really know me, what he had prepared is he had done several years ago is an online dispute resolution platform for small claims. So that's what, when I was still at ERC, that's what I was hoping to develop for any claims, for example, of billing that is below 10,000 maybe, or 10,000 pesos, 20,000 pesos. It can be resolved the same way as we resolve our complaints on our online selling platforms. We don't face people when we want to return a product and want to get a refund, right? So to the extent that we can be as efficient in resolving consumer complaints, then we should explore that possibility. But we were not able to get that far.
Okay, thank you, Attorney. As much as we want to hear everybody's questions to be answered by our speakers, unfortunately, we only have time for one more question.
Sorry, this is not a question.
Yes, can I get your name and
I'm
your organization?
Ebenezer Plorano from the Data Science for Public Policy Program, University of the Philippines. I would like to react to the statement a while ago of Dr. Dimalanta saying that the use of ChatGPT, yes, we can use ChatGPT, but we should be cautious about the use of ChatGPT because it brings out, several answers. And I know for a fact because I made my students in public policy do policy analysis using ChatGPT and they came up with different versions. Okay, and this brings me to the suggestion of Attorney Ocaña that we should localize the creation of applications because we cannot depend, even the commercialization. So that's why I'm advocating, let's look at the black box, okay? We should use explainable AI because with the use of explainable AI, the desiderata of explainable AI is explainability. You can explain how the answers, how the ChatGPT was able to come up with the answers. Number two is interpretability. You can look at the black box and you can see how the model or the algorithm works. And then another desiderata of explainable AI is transparency and also accountability. So let us be careful, especially with the use of ChatGPT for public policy making and decision making, because they will produce, sometimes hallucinations. Thank you very much.
Thank you. Sir, I asked for permission to correct the impression. I wasn't using ChatGPT really to come out with a regulation. It was an experiment that I did because I'm a firm believer of not dismissing any technology unless you have actually, tried it. So it was an experiment for purposes of presentation, so not for any rule making or regulation.
Okay, thank you for all your questions. For those who weren't able to ask questions right now, just a reminder, we still have a fireside chat outside the plenary hall for one-on-one chats, Q&A with our speakers. And with that, I'd like to thank our speakers and our discussants for shedding light on how AI can reshape the energy sector, unlocking efficiency, and supporting renewable integration while also raising tough questions about its own energy demands. As we've seen, what we've heard today makes it clear. Strong, forward-looking policies are needed to balance innovation with sustainability. Now, let's give a warm round of applause for our panelists today. Thank you. And also to our guests for your questions. Thank you. Thank you very much.